Yeah, because I didn't record the D period because I was actually a little too upset to record yesterday. All right, anyway, let's keep moving. K2. Number 2, exponential functions. Now, I obviously didn't have a calculator here. So you make a table, plug in numbers for x, work it out. Now the arrows go in both directions. It goes up to the left and goes towards y equals 0 to the right. If you were to plug in larger numbers for x, ultimately y gets smaller. The asymptote is basically a boundary that the graph goes towards. So y equals 0 is going to be the horizontal asymptote. Domain's all real because you can plug whatever you want for x. There's no reason for restriction. Some of you guys did have restriction or didn't know how to write the domain, but think about it. Why would there be an x that I can't plug in? Right? I can plug in 0. I plug in 1. I plug in 2. I plug in a million. I plug in a fraction. I plug in whatever I want. It doesn't matter. Range. That's a little tricky. I think you have to have a deep understanding what the function is doing. That's why I think coming and talk to me will be good. It's like help understand why this is going towards 0. If you make x really large, think about it. Multiply 1/2 over and over again. 1/2 times 1/2 times 1/2 times 1/2 times 1/2. But multiply 1/2 over and over again, that's getting super small.
Times it by 6.
It's still super small. So still be close to 0, right? So that's why it's gonna be close to 0. And then of course the general shape of the graph and the end behavior, I gave a point for that. Jimmy, yes, question, go ahead.
On the asymptote, I got it wrong.
Sure, go ahead.
Asymptote,
Mhm.
I got the asymptote wrong. But then for question 2, I got the equation of asymptote wrong.
Mhm.
I got everything else right.
Mhm.
And I got -2 points.
Let me take a look. Yeah, if you have any individual questions, I'll take a look at that later because it might be unique. Okay, oh boy. All right, let's talk about part 2. All right. Now, some of you guys did great with it. I really do think number 3 was kind of the make or break question. If you struggle with number 3, the rest of the test was a train wreck. Because exponents is something you guys are still struggling with. And we are going to be, heavy with exponents in this next unit. So we got to figure this out pretty quickly. Okay, 3r squared cubed. So you guys put 20, some of you guys put 9. Okay, am I asking for 3 times 3 or 3 raised to the 3rd power? What am I asking for? 3 to the 3rd power, not 3 times 3. If I wanted 3 times 3, I would have done this, guys, right? I would have done that. I didn't do that. So you have to realize it's 3 times 3 times 3 times 3. You had a calculus, 27. Of course, 27 over 6, reduce, you get 9 halves. You should get R6 as well. R squared is R6. You have R4 in the bottom. You subtract those exponents, you get R squared. Very simple problem. Should only take like 5 seconds. So yeah, R squared, you get R6, R6 over R4, you get R squared. Okay, next up. The bottom, you have -20W7, -4W, -5 raised to the 3rd power. Now we know our properties of exponents. You're going to multiply these two together, right? That's W -15. And we talked about this already. If you have 2 powers with the same base, how do you combine those exponents? You subtract them. You have a calculator. 7 minus -15 is 22. So you should have W22, not W8. Also, some of you guys did this, which I thought was really weird. And again, the conversation I'll have with you will be enlightening because I need to know why you guys are doing this, these mistakes. But some of you guys started off by doing this and then switching everything. Like some put like, well, because I see a negative next to 4, I should move to the top. I see a negative next to 20, I should move to the top as well. And of course, you did that correctly. But then, of course, you did that with W7 incorrectly. Here's the thing. The negative next to 4 and 20, is that an exponent, that negative, or is that -1 times 20?
It's -1 times 20.
Yeah, it's a times. That's not an exponent. You don't move it. Don't move that. Leave it where it is. Just divide -20 by -4, which is 5. That's all. You're overcomplicating things. And what's happening is that you're relying on memory or you're confusing things with exponent properties. Yes, a negative exponent, totally move that. W -15, totally move that. But I prefer you don't move it so you don't make those mistakes and you just subtract instead. Okay, for part C. Oh, Michelle, you're seeing another 10 minutes, Michelle. Thanks. All right, 32. 16 times 2, right? What's root 16? Pull it out. Okay, root y6. So if you think about it, you have to multiply y. You have to take the square of y6. So y to the 3 power times y to the 3 power gets you y6. Right? y3, y3 gets you y6. So it's just the opposite of combining exponents. You're just going the other direction. And go ahead. It's y3. Yeah, I accidentally put y2. It's y3. Yeah. And a root x3 is like saying this. So that's x root x. So that's what's happening there. Jimmy, go ahead.
So it's x cubed. So what I learned was I could put like 3 just like x next to each other.
Sure.
There's only
Okay.
one
Yes.
of
Of x's.
is-
Right.
So is that just it's not x squared, it's just x.
Yeah, because what's happening is that you're doing this, right? You're doing root x squared, which is going to be x. Because x times x gets you back to x squared. Just like when you do root 25, it's 5 times 5, right? It's 5 times 5 gets you 25. Emmy, go ahead. Yes. Oh, great question. Okay. Yes, we are going to curve. And again, I'm not trying to guilt you guys, make you guys feel bad, but the other classes actually did incredibly well. So this class just collectively, I gotta look at myself too, obviously. So I mean, I'm looking at myself what I've done wrong. My D period and this F period were the two low sections. Yeah.
It's like similar to the.
How many classes do you have?
Oh, no, I have two, but we have 8 algebra 2 classes. The other sections did great.
But are the other teachers like other tests like the same?
They're 100% the same. Yeah, they're identical tests. Yeah. Maybe I wasn't I don't know yet, but some of their averages I think were 85, 90%. Our average was about 65%.
Awesome.
I don't know. I have to as a whole, as a section, I think so. I don't know yet. I don't know yet, but I'm pretty sure. Okay, then now let me answer the question. So most likely what I'm going to do is instead of making the test out of 64 points, I'll make it out of 60 points. So everyone gets at least a 5% boost. So at the very least, people should get about 5% boost. But I have to see the overall average. There's still a handful of people who haven't taken the test yet. So, but yes, the other sections did do really well, guys. So we got to figure this out. Anyway, I'm going to keep moving. But I want to be transparent. I don't want to sugarcoat things. I want to be super honest with you guys. Okay, number 4, I don't think it was an issue. If they had problems, talk to me. But for the most part, I think that was probably the best question on the test. So we'll keep moving. Okay, 5 was not good. 5 was terrible. Okay. And by the way, after I finish going over the test, once we bring Michelle back in, we're going to review this kind of stuff again. We got to review fraction exponents and radicals again.
They're gonna be like a unit 2 test part 2.
I haven't decided yet. I'm still figuring that out. So right now, right now, I just want to make sure you guys are understanding your mistakes, and we review. Our next test is not scheduled for later in October, but I'll have more clarity on that hopefully by tomorrow. So, okay. Number 5. You need to convert this to x to the 3/5 power. Okay, convert to x to the 3/5. Then subtract these, that's negative 2/5. Right? And then put on the bottom. So what I'm asking you guys to do is be very methodical in your reasoning. What's happening, I think as well, is the way you guys are thinking about math, it's kind of in disarray. So we need to be able to work on having a more organized approach to the way you think about math. I think that's the thing I'm going to talk about too when I talk to you guys individually. How have you thought of math in the past? I don't know. And actually, I was at some really great talks in Chicago last week where they talk about like in 4th or 5th grade, things you guys work on. So I got a little more clarity of like how middle school math works. But I think some of it also has to be your thought process too. So I need to understand like, hey, did you think to make that radical x to the 3/5? But if you did something else, some of you guys changed the x to 1/5 to a radical. That was probably not the best move to change the numerator to 5th root of x. I would have changed the denominator to x to the 3/5 and subtracted the exponents. That would have been a much more easy thing to do. Subtract the exponent, change it to put it to the bottom, then make it a radical. See how very smooth that was? But I saw a lot of work that didn't make it too much sense. So we need to work on that too. 6 for the most part was fine. Some of you guys are still having trouble finding slope. And again, this is something that has been talked about often in Algebra 1 and geometry. Just got to take the difference of y's take difference in x's and divide it 2. That's it. That's your slope, 5/2. And then just plug one of these points in for x and y and get your y-intercept. Should be 22.5. So here it's exponential. Just take the ratio between those two. That's 1.2. Because every time you're seeing the same ratio between consecutive y values and initial value, if you plug in out any of these points here for x and y, you should get 5 for a. All right. Here. Yeah, this is also a train wreck too. Okay, and now this is where I'm gonna take the blame for this one. I'll explain why I messed up here. Sam, go ahead.
Like for A,
Mhm.
like you said that we like use like first symbol enters A1 plus R.
I didn't say that. That was for exponential growth or decay.
Oh, I thought it was like the other
Nope.
way.
Yeah.
I thought we
But-
could use R.
But where I made a mistake, when I taught this, I should have taught all these formulas all in one day. I should have actually showed you, okay, here's one formula. Here's how this one compares to this. Here's how that one compares to this. What happened, I did this about 2 weeks after this. And that's when CPM does it. So I was following what CPM is doing, but I should have taken a step back and realized, wait, I think CPM is kind of wrong here. I don't think CPM should be doing it this way because it's confusing you guys. So I understand the confusion, and I think that's where I take the blame, where I should have said, like, look, let's talk about problems like B and C together. How are B and C the same? How are they different? They're the same in the sense that you're making money. How are they different? They're different because B says continuously. Continuously means this. If you look at this formula here, continuous means you're compounding money every waking moment. So n is not a number, actually n's infinity. That's what's happening. And if you do that, if you have 1 plus 1 over infinity raised to infinity, that becomes this number called E, Euler's number, which is 2.718. So then we wind up getting this formula instead. That's what I should have done all in the same day when we started talking about finance problems 2 weeks ago. I didn't do that. My apologies. We'll fix it. I think that would have helped you guys make that, because I've taught this just for 20 years. I've never seen these kind of mistakes, but I taught it with a traditional textbook where it actually talked about both those formulas on the same day. So I think that's where I think CPM kind of did us wrong, and I did you guys wrong too. So I should have realized that was not the right way to do it. So we're going to fix this. We're going to look at a worksheet on compounding. I know you guys will get it because it's a super easy concept, but there's a lot that was going on, and it was like totally disorganized. Like obviously this had made no sense because that was for an earlier problem. We didn't have to use this formula. That's for like population, growth or decay or stuff like that. That's simple interest. So that was for part A. So simple interest had to use that formula, which I know we talked about, but again, they're not all kind of done at the same time. So I know it was a little confusing. Some of you guys had some other things going on with part A, but you had to just use that formula instead. 0.2 for R, 30 for the time, work it out. Here for this one, that's continuously, use that formula there. Part C, if you do it monthly, you got to put 12. Sadie, go ahead. The one on the far right. Yeah, because that's one for simple interest. It's like a linear function. Yeah, and again, I should have been more aware of how this is being done in CPM. I don't think CPM did it well. So, okay, I know I'm repeating myself. For part C, monthly, you got to put 12 in for N, right? So that's what happened there. I try to be as generous as I could be. As long as you're plugging in numbers, I try to give you a point at least. But yeah, I didn't go too hot. Okay, the review portion. Some of you guys nailed this. Some of you guys did great. Unfortunately, some of you guys did not. And now this is where I have to get a little more serious about the grades. So if this didn't go well, unfortunately, you lost your opportunity to remediate the Unit 1 test. So the Unit 1 test stays as is. What that means is that most likely getting an A in the class is probably not going to happen. That opportunity probably flew out the window. So you're going to have to be content that you might end this class with a B, and that's okay. What I don't want to happen is I don't want a third bad test in October, because if you have a third bad test, then the best you can probably do is a C. A fourth bad test, you're not passing this class. I don't want that to happen to you guys. That's why I'm taking this very, very seriously. I'm so glad we have parent-teacher conferences. I actually requested parent-teacher conferences with most of your parents. I'm going to be very busy, so be it. But that's how it's going to be because, yeah, some of you guys had trouble with this still. Let's look at number 8. Okay, -5 and 8 are not included. You have to put holes there, right? They're not included. 0 and 6 are included. You make sure they're filled in. Now it's a little tricky, but the thing is that you can't do this. Some of you guys are doing this here. You were drawing like you were doing that, but that doesn't work because 0 and 6 have to be included, right? It's not consistent with information here. Some of you guys didn't make it a function. Some of you guys had it fail the vertical line test. So some of you guys are doing like something like this here, but you can't do that because that's a vertical line that can't work. So you just have to kind of think to yourself, okay, well, -5 and 8 don't have to be at 0. I could do -5, 2. I could do 8, 2, and then make sure I hit 0 and 6 top and bottom. So that works. So you guys, it's just number sense that comes down to that. Okay, for number 9, I think this happened to about 4 or 5 of you guys. When you were plotting this, I'm pretty sure I would actually bet the deed to my house. I'm that confident that you guys did this. That's some of you guys. Division, sorry. When you typed in the TID4 calculator, I'm pretty sure you guys did this. Do you guys see why this is a problem? Rhea, go ahead. Well, bad test, anything below 70%, or yeah, that could be a bad test. So anyway, 4 over x plus 1 plus 2. Okay, you guys see why this is a problem?
You can put a parentheses.
Yeah.
But do you only put a, I was confused, only put a parentheses around the x plus 1?
Yeah, you do.
Like
Yeah.
so I did that, but then it's still like.
Okay, then let me show me your calculator, then we can figure out what's going on.
It did show like I got the right like look of the equation, but it wasn't.
So individually, so this is where the individual stuff is coming to play. So I'll have to talk to you guys. We'll figure it out. Don't worry. So y equals 4 of x plus 3 is probably what would happen if you typed in like that. And then you probably would have a graph that looks like this. Sorry, it's going to go. Let me do it over here. You have a horizontal asymptote at y equals 3 and a vertical asymptote at x equals 0. So you're getting a different thing. If I suspect that's what happened and your answers are consistent with that, then I took up a couple points for that. So I was trying to be as generous as I could be with partial credit, but some of you guys were way off. Some of you guys' graphs were really sloppy too. It really helps to make a table, and we deliberately chose numbers that worked out nicely. Like if you plug in 0, 1, -2, -3, that worked out nice. -1 actually was not okay, because you get 0 on the bottom. So that should be a vertical asymptote. Y equals 2. You would see that, and this is the part where we have to really kind of think to ourselves numerically. Hey, if I'm doing 4 over a large number, what's 4 over a very large number? It's close to 0. But the number close to 0 plus 2, that's getting closer to 2. So that's why we have that. That's why we have the horizontal asymptote. As x gets really large, the fraction gets really tiny. You're adding a tiny number to 2. That's getting very close to 2. Not 2 exactly, but very close to 2. That's the purpose of a horizontal asymptote. Now, I'm going to talk about what we're going to talk about in the future. In the future, we're going to look at other equations like this, where the horizontal asymptote can be crossed. So this is what I'm talking about with misconceptions. I did say it's a boundary, but it's not a boundary that can't be crossed. We're going to see graphs that look like this eventually in the spring that follow the same kind of format. But the true purpose of a horizontal asymptote is not a boundary that can't be crossed. So I don't want to create these misconceptions. But what may have happened is you've had misconceptions about other things in the past, like with algebra or integers or whatever. So we have to make sure, what is the purpose of each of these things we're doing? The purpose of the horizontal asymptote is simply this: the left end and the right end. They're going towards 2. That's the only purpose of it. And your graph had to show that. If it didn't show that, I took off some points. Emmy, go ahead.
X equals -1.
Right. Y equals 2. Yeah, that's what I'm explaining right now. So what's happening is that as x gets larger, as x gets like really big, right? What happens to this fraction here? It gets really tiny. Because you're doing 4 over a large number, right? 4 over a large number is like super tiny, like 0.00001 or something like that, right? Then you're adding on to 2. So guess what y is getting closer to? 2, actually. The fraction is getting closer to 0, but you're adding a 2 afterwards. Now, the one thing I think will help, because we still have to talk about the next unit, and actually we have to still move on to the next unit, because then otherwise I'm not teaching guys Algebra 2 anymore. And yes, correct. In a way, yes, it is. Because we're gonna talk about just wait. I'm gonna do a lesson today on this type of graph again, and I'm gonna talk about how it ties to the next unit. I'll get there in about 20 minutes. But yes, there's gonna be a tie-in between the two. Anyway, the asymptotes intercepts right there. Okay, last one. Number 10. Yeah, I let out a huge sigh here. This one was also really tough for some of you guys. Here's really just think about it, right? You have a problem. You have a line. You have a problem line. How many times could they cross? They could probably cross twice, right? I mean, they could also do this too. They could never touch. Or it could just graze it and touch just once, right? Three possibilities. Most likely, it's going to be that first possibility. You have a graphing calculator, plug it in. Even though I said algebraically, still use your calculator to see what happens. So you expect two answers, right? And you probably know roughly where they're going to happen. That's what I've done first. Then get y by itself. Okay. Once you get y by itself, plug it into the other equation. Solve it. You have a very simple quadratic equation. Factoring, I know for a fact at the school. If you went to our middle school, I know you guys did this. I was on the trip to Chicago with all the middle school math teachers. I know you guys did this if you went to our middle school. You guys have factored. You guys, and Mr. Davidson, I know you guys have for geometry. I even in the room, he did this with you guys. This has been done for 2 years. It should not be a problem. Yet it still is a problem. So we got to figure this out. Why is factoring still a problem? Think about what multiplies 6 as in 7. 1 and 6. That's it. Takes like 2 seconds. 1 and 6, multiply 6, adds up to 7, solve for x, -1, -6, throw it back into the equation, get y, done. Some of you guys got it, some of you guys did not. So we'll figure it out. Well, if you did not get it, I'll try to understand why you're not getting it still. So anyway, that's that. Someone could get Michelle. She can come into the room. We're gonna now move on to this packet. So this packet, I'm gonna make due Friday. I think I have it due Wednesday. Let me go to Schoology and make that due Friday. So we're gonna work on this packet in class. I'm gonna do a good number of these problems with you right now to make sure you guys are understanding what's happening here. Now this packet has 4 problem sets: simplifying exponential expressions, and has the answers afterwards. Radicals and rational exponents has the answers afterwards. Graphing some rational functions, which we just talked about, the answers afterwards about all the asymptotes. And then lastly, compound interest. These are the 4 big ticket items that really serve as obstacles in the last test that we need to figure out. Tomorrow, I see you guys again at the end of the day. We're also going to work more on this in class tomorrow. If you can do some stuff tonight, I encourage you to. I'm not going to make anything due tomorrow, but I think you should put some energy towards this throughout the week. This entire packet will be due Friday. Now, the other packet, that thick one I gave you guys, if you did it, don't worry. I'll give you some extra credit or some credit for it. I actually removed that assignment. So that assignment's no longer due next week. So if you haven't started yet, you get a huge sigh of relief. Be grateful. If you haven't done that thick packet that had a whole bunch of exponents, don't worry about it. But if you have done it, show it to me, and then maybe I'll update like a quiz grade or old homework scores or something like that. I could help you out and give you some extra credit for it. Emerson, go ahead. No, not necessarily. If you've put some effort, I want to acknowledge that. So, because I feel bad. I don't want to just remove it like, oh, you did all this work and you get nothing for it. I want to make sure you guys get something for it. So I want to be fair. I mean, of course, the practice is good, right? But if you're feeling the pressure, like, oh crap, I gotta do this and I gotta do that big packet, don't worry about that big packet if you haven't got there yet. Don't worry about it. Yeah, exactly. It's the really thick one. Don't worry about it. But I will think of something if you did do it, like maybe if you had some bad homework quiz scores, I can give you full credit for those, just to boost your grade somewhat. So, because it'll still give me a homework score anyway. So, all right. So let's start over here, guys. Properties of exponents. Okay. Now, the other thing I should have done too. Okay, another thing I'm gonna do as well. I mean, I know I'm talking a lot today. I apologize, but I need you guys to be doing stuff as well. So I promise tomorrow's gonna be more of you guys doing stuff. I'll put stuff on the. I'll probably use the walls outside and put up some practice problems, maybe stuff on the boards. Amy, go ahead.
For like for problem number 1, I know that it's 4 to the 6.
Yes, good.
But would I leave it 4 to 6 or would I?
You can leave us 4 to 6. It's fine. Yeah, that's fine. Yeah, I mean, you can multiply it out if you want to, but yeah, and actually, if I look at the answer key, I think it says just 4 to the 6. Yeah, it does. Yeah. Okay. Now, what I should again, what I should be doing more of is have you guys do more practice, me less talking. I know I'm talking a lot. I apologize. Again, promise Wednesday we'll do practice problems. Yes, I think so. Yes, yeah, I think so. And I think the new table groups will help with that too, because I think there's more balance now with the table groups, which is good. And there's less friends. I mean, you guys are friends, but friendly. We'll just put it that way. Because I want you guys to be working hard and doing well, not getting distracted, right? That's why I moved the table groups too, as you can tell. Anyway, but another thing I should do also, which I probably should have been more deliberate, and CPM doesn't do it this way, but again, I'm going to try to use some CPM stuff, but do some of the stuff that I feel you guys need. You really should be doing stuff like this, like writing things out the long way, so you can see why this works the way it does. Instead of just using the properties of exponents, which we take for granted, let's understand why does the properties work? Why can I add 1 and 5 and make it 6? You see, but what does 4 to the 5th power mean?
4 times 4, 5.
Yeah, exactly. Right, 100%. So let me color code. So that's, we have 1 4, and then how many other 4s do I have? 5 more 4s, right? And if I do a quick count, just use your fingers, 1, 2, 3, 4, 5, 6. That's why it's 4 to the 6th power. That's why I can add the exponents in that situation. That's why we add exponents. We never add exponents any other way except that situation. So we have the shortcut. We're grateful for it, but we have to understand the long way too. So we appreciate the shortcut. Let's look at another one. Let's look at 5. How many 3s do I have in the numerator? If I 3 to the 5th power, what does that mean? Exactly. How many 3s do I have at the bottom? Okay, good. So now let's take a look at it. Here you have 3 over 3. What does that become? Great. So that just goes away. How many 3s are you stuck with? There we go. 3 to the 4th power. That's why you can subtract exponents. Okay, so hopefully just by being more slow and deliberate about it, that might help. Now, when I get something that's kind of crazy, Amy, go ahead.
Like, I get kind of confused about like for like 3.
Mhm.
So for the exponent of -2,
Mhm.
it applies to 4, right?
It applies to only to the -4 exponent. I'm going to get there in a moment.
Applied to both, or-
Right, and I'm going to clear that up. That's good. I appreciate the transparency, honestly. Thank you for that. So before I get to 3, I'm going to get there in a moment. Let's take a look at like something that's a little more complicated. Like let's say let's say like number 13 really quickly. Let's look at 13 really fast. So I have 2 squared, which I know is this, right? I have 2 cubed squared, which means 2 times 2 times 2. And of course I have another 2 like this. So when I work it all out, it's going to be kind of crazy, right? Like how many 2s do I have on the bottom? If you do a quick count.
Oh, 8 with the exponent.
Actually, a little more. Let's do a count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It's a lot of 2s, right? But this is where the shortcuts will help us. That's 2 to the 6th power, because you can multiply these 2 together. So that this 2 goes to, we have 2 cubed squared. That means I have 3 2s and another 3 2s. That's 6 2s altogether. Or you could just multiply that out. And of course, you have 2 to the 4 as well on the bottom. So it's 2 to the 10. You have 2 squared up top. Now, why do we have these properties of exponents? You could write out all the 2s again, like I just did. There were a bunch of 2s here, right? And there's 2 2s up here. And when you cross things out, let me just write it out again one more time in long form. I know it's very tedious, but I'm just going to do it just for the sake of doing it. Okay, that's okay. See these cancel. How many 2s do I have left now on the bottom? Exactly. But instead of actually doing it like this, which is a total pain in the ass, I wouldn't do it. I would not suggest to do it this way. What shortcut do I have? Subtraction, totally, right. And I'm gonna use like just dumb analogies, but like, for example, if I want to get to San Francisco, I know there was work on the freeway over the weekend. I discovered that when I was coming back from the airport. But if I want to get to San Francisco, like, yeah, sure, I could go down to San Jose, take 880, go through Oakland, take the Bay Bridge. Or I could just hop on the train or take 280 or 101. So we don't want to take the long way because it's not fun, right? So we want the shortcuts, but in order to appreciate the shortcuts, we have to understand why it works. It works because we get this, right? So the shortcut means, hey, let me subtract 2 with 10 here. What's 2 minus 10? -8. And we have negative exponent. Where does it go? On the bottom. Negative exponents, whenever you have negative exponents, they always go on the bottom. Some of you guys are still putting a negative out in front, but that doesn't make sense, right? Because that's not the purpose of it. If you had negative being multiplied, sure, make the answer negative. If you have a negative exponent, you don't make the base negative. You simply put the base on the bottom. Base goes on the bottom now of a fraction. So that's why we have the shortcuts. Exactly.
Would it be 1/1 now? Because it's like 2/2, and you divide by 2.
2/2, what do you mean?
This is like 2.
Okay, so I'm glad you brought that up. We don't do that because here's the thing. I know what you're doing now. You are doing a PEMDAS error. You're dividing this 2 by 2. But what comes of fourth division in PEMDAS? Exponents, exactly. So you're bypassing order of operations.
Yeah.
You got to subtract exponents.
Okay, but then you don't divide after.
No, because they already combined.
Okay.
No, you don't divide out. Yeah, that's what's happening too. Is I think you guys are messing up order of operations as well, which again was covered during the height of the pandemic. You guys are doing on Zoom school. So, I want to, acknowledge that too, that, there's still some COVID stuff we're dealing with too. Let's look at 3. Now let's talk about 3. Let me do it long form and then we'll do the shortcut. Okay, long form would be this. PEMDAS. Do you see parentheses? Yeah, let's take care of it, right? Let me take care of my parentheses. So that's going to be 1/4 to the 4 power, right? That's what it means, right? Because you have the negative exponent side. And what does that mean next? How many 4s are on the bottom? Perfect. Good. Okay, now I'm raising to a -2 power. What does that negative exponent do? Well, if it to turn to a positive exponent, it flips the fraction. How many 4s do I have now, guys? But I'm squaring. You have 8. Yes. So that's why the answer is 4 to the 8th power. That's the long way of doing it. I should have actually done it this way with you guys when we did CPM. I didn't think to do it that way because CPM doesn't do it that way, but I should have. Because then we do shortcuts afterwards. Rhea, go ahead. Yeah, hold on. Let's Rhea first. Go ahead. Exactly. That's the best way to do it. Yes. Is that what you're saying, Amy? Yeah, exactly. What's the easiest way is just to do this. Yeah, so it doesn't go there, it only goes to the exponent. Because when we see the long form, oh, cool. We're supposed to have this 4 repeat 8 times. So that's why it's 4 to the 8th power. Okay, now that we're cool with that, let's look at a more complicated one. Let's move on to the next set. Let's take a look at say 32. No, let's look at 30. Actually, let's look at 30, 32, and then 33 and 34. So I'm doing a good chunk of these with you guys. So, all right, let's start at 30. Okay. Think about PEMDAS, right? It's I don't see a parentheses, but it's kind of like there is a parentheses. It kind of is there. So let's look inside the bottom. So what's happening here? The 4R5 times 4R-5. I do see exponents. I see an R5. I see an R-5. Fine. I also see 4 times 4. What's 4 times 4?
16.
Great. And that R5, that 5th power is not to the 4. That 5th power is only to the R.
5 plus -5 is 0, so you're 16.
Correct. Good. Well, so right now you have R5 and R-5. Those cancel out. Good. So it becomes R0. And that's just 1, right? We talked about when you have this, that's just 1 because you don't have any R's. Correct. Now the R-2 goes on the bottom because it's a negative exponent. And your final answer is out. 1/16 R squared. And I'll be honest. I mean, are you going to ever use these things later in life? No. Just if we look at 2 or 3 years from now. I mean, again, I went to some talks in Chicago. They said, like, why do we have these kids do all these things? But here's the thing: you are moving onto a path. And again, I'm not going to told BS you guys are, I'm going to be totally transparent. You guys do want to go to college, right? You do want to have a good chance of getting to a good name school in a couple years. They do want calculus. if you're a sophomore, you're on the trajectory of taking calculus. And that's just how life is. I think math might look a little different in a few years from now. Like maybe there might be other classes that colleges will be more accepting of. But right now, they want you guys taking calculus. You got to be good at this stuff if you're going to take calculus. I'll tell you right now, calculus will be really hard if you're struggling with exponents. So we have to make sure exponents are in good shape because exponents have to be pretty much second nature by the time we get to calculus. So pre-calculus also is the expectation that you guys are good with exponents too. So the negative exponent goes in the bottom, 1/16r². I know it seems silly, like, okay, like this is not terribly interesting stuff. I get that, but we have to be good with this stuff so that we're successful in our future math classes. All right. Next up, let's look at 32. Excuse me. Now we know our properties, we just use it, right? That's x to what power? If you have x to the 5th, but a -2 on the outside. Good. And x to the +8. Then let's look at the two x's on the bottom. X to -10 times x to 8. How do I combine these exponents if the bases are the same and I'm multiplying the two powers? Addition, exactly. And then I said these are identical, so it just becomes 1 because they cancel out. Or you subtract it. If you subtract -2 with -2, that'll work. You get x to the 0 power, which is still 1. Okay, let's keep moving.
Oh, yeah.
Oh,
Oh, yeah, we did it as an X. It's a Y.
you're right. Sorry, my apologies. Thank you, Ria. Okay, well, yeah, I'm human. I make mistakes too. All right. Thank you. It's Y8. Okay, actually, well, anyway, if it was an X, now you know. Thank you for catching that. I appreciate it. Let's subtract the exponents now, or you can move them. You can move them, sure. Only negative exponents move though. Only negative exponents, not positive exponents or numbers stay where they are. Then it becomes this. Okay, now I got it right. Yeah, my apologies. For 33, that's a trick question. Why is that just 1? The whole thing's raised to 0 power, exactly. Right. And if 34, that's going to be M8, not M6. M8 over M5, and that should be M3. Right? Because you have M squared 4 times. But here you have M3 and M2, that's 5 M's on the bottom. M8 over M5 comes M3. So you have plenty more to practice with. Okay, let's keep moving. Okay. Radicals and rational exponents. So we talked about this too. When you have a number, I'll put x raised to the a over b power. Then it's supposed to be this. Okay. Right. These are interchangeable. They're basically the same thing, right? So I'm going to do a double arrow because you can go back and forth between these two. You have to be incredibly fluid, especially in calculus. You have to be incredibly fluid with this. Again, I know I'm talking about calculus. We still have to finish this class. You still got pre-calculus next year. But, ultimately, we have to be very comfortable with this stuff. So when you have a fraction exponent, it's the same thing as a radical. The denominator of the exponent is going to be the roots. The numerator is what you raise it to outside the parentheses. Okay. So let's look at number 3. How would I rewrite that? What would that become? Go to Amy. Perfect. That's it. That's all I do. That's all it is. What that is crazy. Some weird number punched in a calculator, but that's what it is. Yep. 100%. Now, if you see a 2 in the denominator, like for example, for number 6, I could write like this if I wanted to. It's kind of weird, but if you have a 2 as a root, usually we don't write the 2, and you assume it's what? Exactly. And because square means 2. Right. But you don't write it because it's kind of redundant. But yeah, you get that. That's right. Okay. Now let's go the other direction. In the other direction, we have this. Excuse me. Let's look at number 9. So what's going to be the numerator and denominator of my exponent here?
-2
Mhm.
to the 4 over 5.
Other way around. 5/4. Right? 5/4. Correct. Okay.
Oh, yeah.
Right. How about number 7? How would I write that as a exponent? 10 raised to what power?
3/2.
3/2. Perfect, right? 3/2. Because if you see a square root, you assume there's a 2 there. That goes in the bottom. Okay. So this would be good practice. Go back and forth between these two. Yeah. Okay, now let's look when there's things being combined, like with numbers and letters. So let's look at 13. There's a negative exponent that's going to go on the bottom. Go ahead, Amy. Oh, which one do you want to go back to? A 12, yeah, how would you write it?
I don't know. 'Cause there's-
Okay. Yeah, so you assume it's a 1.
Oh, so you just do 10 to 6 or 1 over 6.
Exactly right. You assume it's a 1.
What happens with 6 over 1? Where do you-
No, you just do 6.
10 to the 6th power. Yeah, then it'd be 10 to the 6th power, right? Because you're not doing a radical at all. Right. Okay. Let's look at 13. All right. For 13. That's 1 over, right? Because it's a negative exponent. Okay. Then what's going to happen next? You have to do a root. A 4th root. 5x stays inside because you have a parentheses. And that's being risen to what power? To the 5th power. 1 over 4th root of 5x raised to the 5th power. Okay, we good with that? Yeah, and you have more to practice. Let me do one more. Let's do number 17. You have 1.5. What's 1.5 as a fraction? If I change it to a fraction.
3 over 2.
Right, because 1 plus 0.5, right? Or 1 plus half, which is 3/2. Thank you. So you have that. And you work it out. Square root 6v cubed. Okay? Square root 6v cubed. By the way, you could do 6v cubed first if you wanted to, then square it afterwards. But better to root than do the cube afterwards. So yeah, so I'm hoping the repetition will help. So you guys start seeing the patterns. Okay, let's keep moving. Let's take a look at this right here. Actually, let's just move on because I want to go to the other packet. I think you guys get the idea. Okay, let's do 19 or 23, and then we'll move on to the next set. Okay. So what's the so m raised to what power? What's gonna be the fraction exponent here? A 3 what? Perfect. Thank you, Fernanda. Yep, 3/4. Okay, so we get 23. Actually, let me do 24. We'll do 24. It's negative. So because it's in the bottom. And what's a fraction here? Perfect. There you go. You got it. Good work. 3k raised to -5/2. I know this starts getting abstract, mind you. Yes, this totally gets abstract. Because then all of a sudden, like, wait, what is that really like when we had like M8 over M5? That's more tangible because you see, oh, I got 8 M's up top, I got 5 M's down below, and I take them away, right? You can visualize that really easily. It's getting pretty abstract now. Totally. 100% it is. Oh, I got which one? Sorry. Number 24. So you have something on the bottom. So it's gonna be a negative exponent. Well, actually, before I do a negative exponent, let's do this. Does that make sense? Do 3k raised to 5/2.
Top.
It's gotta be negative. Yeah. Right. But we do see a 5, and we do see a square root. So that's why we have a 1/2, because square root means 1/2 is an exponent. And you see a 5, so 5 times 1/2 is 5/2. And then it's on the bottom. So if you want to bring it to the top, it would be 3k to -5/2. Yeah, Jim, what's up? There's not, but if you go to the bathroom, I think there's some paper towels. So, or in the hallway next to the bathroom. Okay, let's keep moving because I do want to move on to, and we're gonna work on this tomorrow in class. Don't worry. But try some tonight. Okay. Now here, I'm gonna pull up Desmos. So I mean, obviously you probably have to use a graphing calculator, but
CLG specs. Yeah.
assembly. Short assembly. Okay. So let's take a look at number Number 2. Okay. So punch this into your calculator. Y equals 4 over. And this is why Desmos is better, because it doesn't have the issue with the parentheses. Okay. There's a graph. Okay. So I just punched in the graph, right? This is number 2 on the next set. Here's the equation, right? 4 over x minus 1 plus 1. Okay. This is going to be a great segue to what we're going to talk about in the next unit. We're going to talk about transformation of the graphs. Like, we're going to look at parabolas and other stuff, move things around. You guys did transformation geometry, right? You guys did like that stuff. See that stuff in the walls there? Like, I learned that last year. They rotate, move things around. Not quite that complex, but I'm going to talk about transformation in just a moment. But let's think about this equation here, right? 4 over x minus 1 plus 1. Okay. What value of x is not okay here?
1.
1, exactly. And we see a plus 1 on the outside as well. Now look at the graph. Look at the scale here. This goes from 0 to 10. So 2, 4, 6, 8, 10. Okay, that's 2. So I look at this graph, it's definitely, y definitely equals 2 somewhere over here. And then look how this red line just kind of sort of just goes straight vertical. Look over here as well. Like this crosses the y-axis, fine, but then see how this line does this as well. It seems like there's some sort of boundary happening here. Where's that boundary happening? At what x value is this happening at? Close. No. What border is between these two curves? Like what line would be right in between these two? What do you think would be right in between these two curves? X equals 1, exactly, right.
The other one has. Yeah, because
No,
the graphs in every line is like plus like 2.
Oh, look at scale. Sorry, scale's 2, because that's 10. So look at the grids. Yeah. So I sorry. Now I understand why you guys were confused. So if I do x equals 1, and let me make it. Okay, well I can't make it dash, but you see how the blue line separates those two, right? So that's the reason why that's happening. Now let me do this. Let's look at y. Okay, you guys see the same scale here. 2, 4, 6, 8, 10, right? Take a look at what's the graph doing horizontally. As I go further to the right, it seems levels off, right? Like this is not going to the x-axis. It's kind of just sort of staying stagnant. Likewise over here, the x gets really negative. It's not rising anymore. It's kind of flattening out, right? What's happening? That's y equals 2. Sorry, y equals 1, my bad, sorry. That's y equals 1. See how y equals 1 separates those two graphs as well. So those are my asymptotes. Now, this is the part that's going to really tie nicely to what we're going to talk in the next unit. There's a general formula that looks like this. We didn't teach it to you guys because we wanted you guys to first understand how to use a graphic calculator, as well as understand numerically what's happening. I didn't just give you guys this formula. And the reason I don't give you guys this formula is because when I do give you guys this formula right away, and then like you guys go through algebra 2, goes through pre-calculus, by the time you move on to calculus, you forget this stuff. I want to make sure we understand numerically what's happening. But here's a formula that you can use. A over x minus h plus k. Let's do a quick comparison between this and this. What's in h's place here? No, in h's place.
Oh, it's just like -1.
What's
Actually, positive 1.
-1.
No, because there's a minus already here. So it's just 1 straight up.
Okay.
What's in k's place?
Wow.
1, exactly. So h and k are what we call transformations. H is what I call a horizontal shift. K is what I call a vertical shift. We're going to talk about this tomorrow for sure.
Would you also know, like, for finding the asymptotes for this equation, when you know for x, it's gonna be 1.
Exactly.
So
The number on the outside, 100%. And that's what I want to talk about. Like, what if I have y equals 4 over x? So let me clear this right now. Yeah, look at the blue curve, look at the red curve. See, what's happening is that notice how the blue curve, if you want the blue curve to match the red curve, you have to shift it 1 right and 1 up. So if I were to add 1 to this, see how they line up horizontally? And if I do a -1 down here, obviously they become the same thing. And that's what's happening with these graphs here, is that you can actually look at the numbers being added or subtracted on the outsides to do the graph more accurate. Like, let's look at number 5, for example. If I compare this to this general form I just told you guys about, that +1 means I have to go 1 left. that -2 means I have to go 2 down. So it means I'm gonna have an asymptote at -1 and a horizontal asymptote at -2. And if I make a quick table and plot points, I know I'm gonna do this kind of sloppily, but I'll just do it anyway. I'm doing a sloppy way. But I know the graph's gonna look like this based upon the shifts that the graph's experiencing. We're gonna talk a lot about that tomorrow. But initially, what can you not plug in? -1 for x, well, Caitlin. And y is gonna be getting close to -2 as this fraction gets closer to 0. Caitlin, go ahead.
Is always going to be like the
Horizontal.
y.
Yes.
So-
Yes. Yes. Exactly right. So, but for now, go to Desmos. Do this in Desmos, guys. It's totally fine. Go to Desmos. The domain and range. I'll show you one of the answers here. You see that the answers are right here, right? So you have the answers you could check out. So we'll talk more about this tomorrow. I know we only got about 2 minutes left. Really quickly for compounding interest, let's just take a look at both say 1 and 3. For number 1, you use this formula. Oh, that's fine. That's okay. Yeah, that's okay. Oh, I do need a test back from you guys. Yeah, sorry. Anyway, those are the formulas. We'll talk about it tomorrow. So, you can leave stuff here. That's fine. Don't do that. That's like, I think it's 97.
Caitlin, what did you get?
Like a 96. Are you kidding me?
What?
Yeah, there's 62.
Like a 96.88. The exact same thing.
No way. Yeah, carbon.
Are you gonna put in the, for unit 1?
I think I may have written it down. You do, yes.
I'm not.
Yeah,
but it's not very.
All right, guys. Have a good assembly.
I got 62. If you're curving it to 60, I'm gonna go 100.
Yeah, just to be fair to the other classes. So, yeah.
Okay.
Yeah.
Thank you.
So I got like a 82 on the unit 1, but my grade it still says like 72. It's like my original test.
Number 1 got 8%.
There's on the first test, I got a 72. Or 72. But then you know how there's like the retake.
Oh, yeah, you did get an update.
Yeah.
Did I update your request?
I don't think so.
Yeah, it's probably get a chance, yeah.
Okay.
That's probably what happened. Yeah.
Thank you.
Yeah, no problem. Yeah, I mean, I was scrambling trying to get grades done, so, and I got back late on
Yeah, no,
the weekend, so.
thank you, Mr.
Yeah, see ya.